Ever wondered how your phone can transform a stack of blurry photos into a 3D model of a landmark? Or how filmmakers craft those mind-bending virtual worlds? The answer lies in a revolutionary process called 3D reconstruction, and today, we're diving deep into the science behind it. Let's start with the fundamentals. Imagine you're trying to map a room using just a smartphone camera. You snap photos from every angle, but they're all disorganized. How do you determine where the walls are, where the furniture sits, and how the camera moved? That's where structure from motion, SFM, steps in. Traditional SFM methods require images to be tightly connected, like a puzzle. But what if the photos are sparse or only slightly overlapping? That's where incremental SFM shines. Here's the breakthrough. Instead of processing everything at once, the system builds the 3D model incrementally. It starts with a pair of images, calculates the camera's position and the 3D points in the scene, then adds more photos one by one. Each new image acts like a puzzle piece, fitting into the growing model. This approach is incredibly flexible. It handles missing data or noise far better than older methods. But how does this magic happen? Let's break it down. First, the system detects features in the images. Think of this as identifying landmarks in a city. The SIFT algorithm excels here, pinpointing unique points that remain consistent even when images are scaled, rotated, or lit differently. These features act as visual fingerprints, allowing the system to recognize the same objects across multiple photos. Next, the system matches these features between images. It's like cross-referencing a list of landmarks to see which ones appear in both photos. But not all matches are reliable. Some are just random coincidences. That's where RANSAC and the 8-point algorithm come in. They filter out noise, finding the most trustworthy connections to estimate the camera's movement between shots. Once the system has a rough idea of the camera's position, it uses triangulation to calculate 3D points. Imagine two cameras capturing the same scene. By comparing where a feature appears in both, you can determine its depth. This creates a sparse 3D point cloud, the skeleton of the scene. But the real secret sauce is bundle adjustment. Think of it as a precision tuning process. The system constantly refines camera positions and 3D points to minimize errors, ensuring every landmark aligns perfectly. It's like double-checking your map to guarantee accuracy. Researchers tested their method on real-world data, measuring success through reprojection error, how well the 3D model matches original images, and camera trajectory coherence, how smoothly the virtual camera moves through the scene. The results? Their incremental approach held its own against tools like COLMAP, proving traditional methods still have vital roles, even in an AI-driven era. So why does this matter? From restoring ancient ruins to training self-driving cars, incremental SFM is pushing boundaries. It's not about replacing old tools. It's about empowering researchers with a versatile, robust framework. Whether you're a developer, a filmmaker, or just a curious mind, understanding these techniques opens doors to a world where 3D reconstruction turns pixels into reality. Thanks for watching. If you want to explore the math behind bundle adjustment or dive into how neural networks are reshaping SFM, hit that subscribe button. The future of 3D is here, and it's more fascinating than ever.